Hello and welcome back again to the CodeMaven Programming Bootcamp. Hi Laura.
Hi.
In this video we are going to talk about modules. So let me switch already to the screen. Okay, I lost the button. Yeah, I found it. Okay, sorry for that. Yes, okay, so this is the main screen, and then in the slides we are talking about modules. We already talked about functions earlier as the first tool that allows us code reuse. So one of the goals of functions was to be able to use the same code to run the same piece of code from multiple places in your project. The next step is to move out pieces of your application, functions actually, from your application into separate files. So you will be able to reuse the same function from multiple scripts and from multiple projects. Okay, and we basically saw a couple of these examples already when we used the sys module or the I don't know if we saw it, the CSV, the mass modules. These are all, I don't think that we saw actually the CSV module, but there are all kind of these modules that allow us to use further functions that are not built in Python. Okay, and as I think I mentioned, or I'm not sure if I mentioned, let me show you this site. So this PyPI website, I think we saw it already. This is the main central place where Python developers upload their modules, and then publicly. These are all open source modules. These are the number of, they call it projects. There are the things that you can install within the thing. Well, we can call it a project. What you can, distribution or whatever we call it. The thing that you install, it can have multiple of these modules in it. Some are really small, some are huge, and so on. But having modules or creating modules, it's not a requirement that you then upload them to some public place. Okay, so using modules is also really good for internal projects. Even for my own projects, when I'm using my own alone, it's good for splitting up code into modules. So that's what we are going to talk about. There are a couple of goals with modules. It's further to the code reuse, what I just mentioned, and it also allows us to have the separation of concerns. So the same thing that I mentioned in functions, and then we actually did it in the last exercise, that we split out a function that did one thing, which could theoretically be reused in other parts of the world of the program or another program. But even if not, just because you have a single thought of something, it's good to have it in one function. Now, in modules, you can put together related functions into a single module, and then actually it's done in the advanced material. If you talk about object-oriented programming, then usually one of these what we call classes, they encapsulate the behavior and the information about a single something. Okay, so but we're not going to talk about object-oriented right now, so let me not skip there. So that's the primarily the goals of modules. And let's now take a couple of examples. So we start with a simple script or simple program that has a really simple function in it, which we are using. Okay, that's what we did so far. We had a program with a function in it. And we can run this and it will print out 5 because it adds up the a plus b. Okay, how can we make this add function reusable by other programs as well? And this is what we can see in the next slide. So we have created a file that only has the function in it. And in this case, I called it my_calculator.py. So this is just a regular Python file, nothing special here. Or maybe the only thing special is that you don't have anything outside of the definition of functions. That's usually what you have in modules. So you don't have anything. So if you run this program, You could just type in Python mycalculator.py, and it would just do nothing because nothing gets executed. The functions are going to be compiled or understood by Python, but nothing else happens. And then so that's what we call a module. And then we have a separate script or program in which we are importing that module. So we say import and name of the file without the .py extension. Okay, that's how we import the module into the memory of this program. And then we can use the add function by saying mycalculator.add.
So here, your file, mycalculator.py, could be anywhere in the system, anywhere in the
Okay, so that's the next slide. I will answer your question.
Okay, sorry.
Right now, we have it in the same directory, in the same library. And that's one of the behaviors of Python, that if you're trying to import something, the first place it will look for the respective .py file is in the same directory where your program is. And then in the next slide, we'll see where else it looks for, or what else to do. But that's the basic. Okay, and then that's it. So that's one way to use it. The other way is to say from mycalculator import add, and when we are importing stuff, we already saw that you can do either. Okay, so in this case we don't have the mycalculator object in our program. We only have the add function. Okay, and then we can call it add without the mycalculator dot the beginning. Okay.
Which one is more useful usually?
So, well, it all depends, and there are actually a couple of other ways to do this. So, if you have multiple functions, so think about having multiple functions. Okay, add, multiply, whatever. If you import it with mycalculator, then you can use either of them with mycalculator dot and the name, because you have the whole module in your the whole module is accessible through this name. Okay.
Right.
You could actually also say import mycalculator as, and let's say CL. Okay. And then you would be able to use it. Well, examples, modules. Let's go there. Modules. Okay. So here, this is, wow, way too many. Sorry. Okay. So we have the add function here. Let me try to change this. So one of the other things that you could do, let me copy this. Okay, copy, add s. Okay, so I could do the following: add s, import mycalculator as calc, and then what we do is importing the whole module, the whole name, but renaming it to just be calc. Okay, this is one thing that we can do. And if I call this Python, it works the same way. Okay, so why would you do this? And why is the other thing? If the name of the module is long, then you probably don't want to type in every place mycalculator.something, mycalculator. It's too much typing, too much text in your code, so on. So maybe you shorten it. And you will see that some of the examples, the more or less standard way to use modules is with this, in some cases. Okay. But then back to the question, which one of the two of these is better? So in this case, I could also import several of the functions. If I had functions, I could say from mycalculator import add, comma, multiply, comma, something else. Okay. The thing is that it's gonna be, so this is shorter now. Okay. So this is much shorter than this. Okay. But then if I look at the source code, so if I don't see this because I have a long if I don't see the first line, the from, I just see somewhere below the calling of the function add, then I might wonder where is this add function from. Okay, so for that, it would be clearer for the reader to have the full name. saying that I mean, I don't have a clear saying which is better. Okay.
Right.
Some people prefer. It all depends. People prefer this. Some people prefer that. I think if both the name of the module and the name of the functions are long, then you would probably prefer making them shorter somehow. You can use this alias thing that we just saw. You can say that you just import one of them. Okay. The question that some people ask, especially people who are coming from programming background, is which one saves memory? Okay, because people think, okay, here I'm importing the whole module, and here I'm only importing the function. In fact, what happens is that in both cases, Python loads the whole module into memory. Okay, so it doesn't matter for memory-wise. The only difference is what name, what object in the module is mapped into your function, into your program. So the difference is only this connection between the module that's in the memory already and your program. But in both cases, the whole loading into memory is the same. Okay, so you don't save there. Did I answer your question? Okay.
Yeah.
Way too long. Okay. So the other question you had is where do you put the file? And the one thing is that, so there is this list here, and I think I don't know. I copied it a long time ago from documentation of Python. It might have changed. This is the list of places or ways that Python is looking for a module. At the end, this is not really interesting, this whole story. What's important is that Python is looking for the module in the same directory where the program is, okay? And there is a list of places which can be found in, is it here? No, I'll show it in the next slide, which can be seen in the syspath variable that Python is looking for the modules there, okay? And when you're installing something, then it automatically installs in these standard locations. So you don't have to worry about that. If you just unzip something, then you have to think about how to make Python find them. So where Python is looking for, the main places can be found is this variable. So if you import the sys module, then there is a sys.path, which is a list that contains a long list of basically directories and zip files. And Python is looking for all of in all of these for the module that you gave it, that you're trying to import. Okay, as you can see, the first one is actually the same directory where my script is. And so Python will look for, if you are importing, what was that, my calculator, then Python will look for, first of all, the mycalculator.pyc file, and then the .py file throughout all these locations. And the first one it finds, that's what it's going to load. So how would you, really interesting question is, how do you organize your code? And then I have two ways here that I show. Actually, probably I should show you a third one as well. Let me show you the first one. So the first one is that we have a project, and in the project, flat directory structure. Everything in the same directory. My script, another script or program, whatever you call that you are going to run, and the module and maybe more modules and everything in the same directory. You don't have to worry about anything, because each time each script, when it tries to load the module, it will find it because it's in the same directory. Okay, so this flash structure is probably the best thing that you can start with. There is another structure that I use, which is using relative passes. Let me show you. This is how it looks like. Okay, so you have a project root directory, and then in there is a bin directory, and in the bin directory there are the programs or scripts, and next to the bin directory there is a lib directory for folder, and in there are the modules. that's another structure that can work. Okay, but now you have to somehow tell this function, from this function you have to find the module which is in a fixed location relatively to where you are. So you can put this whole structure anywhere in your file system, or that's what I would like to be able to do. Okay, so how do we do this? We have to calculate the relative class from here to here.
Why do you call it bin?
Bin binary, I think that was the original. So if on Unix systems, the executables are usually in the USR bin directory, because I think it's originally from binary. I'm not sure actually.
Because ever since I've been seeing this everywhere and I've learned English, I always wondered why would you put your important stuff in a place called bin, as in like.
Right, yeah. That's it's a funny thing, yeah. Yeah, no, so it's bin because it's binary, I think. I'm not exactly sure, but that's usually that's what I thought now. Okay,
right.
So how do we calculate this relative pass? Well, first of all, a couple of steps. If we have, sorry. I just remembered why do I have this slide here. Okay, so before the relative pass, okay, another way is to use absolute passes. Okay, so you take your module, put it some fixed location in your file system, and then you have to tell your script that in that fixed location. And it's not really a recommended way, but I see this happening in projects. Okay, and then what you would do is you say that sys and then sys pass insert. You would like to put it in the first place, so index 0, and the pass to this place. This is a Linux pass, Unix pass. You would put in C colon something.
How come this is not recommended? This seems like a very logical thing.
Right, but this means that you have to put the file in that fixed location. You can't put it anywhere else. So if I use this one, you can't use it because you have a Windows machine, and on the Windows machine you don't have this pass.
Right. Okay.
Okay, and even if you have a Linux machine, probably your name is not foobar. Okay. And so these fixed passes, that's the problem. And there's another problem. In many cases, you would probably want to have a version of your program that is what you call the production version. So that's what you are using, okay, daily. And then you might also work on a development version of your product, of your code that you're currently improving, but it's still not perfect. So you still can't use it for your next version of your code. Okay. If you have a fixed class, you will only have one location to put your modules. If you are using something more flexible like a relative class, and that's what we're going to see soon, then you can put the whole structure in multiple places, and they all will really use the relative version of the module. Okay. So this is the relative one, where we have the structure, and then this is my module. Okay, so it doesn't have much, it's just a function. It prints out that's hello from my module. And then we have to calculate the relative class. And here is what I would have the code in the code, and then the next slide I'm going to explain it. So this expression calculates what is the root of the project, so the path to this directory. Okay, and then I say sys pass insert, the 0 space, from the project root, add the lib directory, combine them, join them together, and insert that as the first element. And then I can import the module. Okay, so let me explain these things. First of all, let me explain this one. So you remember the join function? Do you remember that you can give it a list and something that connects them, and then it joins together and creates a new string. So this is basically what we would like to do here, but in Linux you need to put slashes, And in Windows, you need to put backslashes between the elements of a path. Okay? So, and in other operating systems, you might need to put something different. Okay? Currently, I don't think that there are actually any other operating systems that use something else, but I worked on one that had columns between parts of the directory structure. Okay? So this OS path join is like a join, except that it knows on what operating system you're running and can put in the right version of the slash, sorry. Okay? So this is the OS module and OS path join. And then you give it pieces of a directory path and it combines them together. So when the project root points to this place, it adds the slash or backslash according to your current operating system. So what is this thing? Let's go to the next slide. So there is this variable called _file that contains the name of the current file. Okay? You can use the OS path upsplash. Let me show you. Okay, so when I run this program, this is what path has. This is, sorry, what _file has. Because I ran it, I was in the examples directory, or actually above it, and then I ran this program. So this is how I code the program. This is why file, this is how it calls itself. OS path upspath calculates the absolute path from the beginning of your file system. So in Windows, that would be C something, C colon something, or D colon something, or depending on where it is located. So this calculates the absolute path. OS path dir name takes a path and removes the last part and gives you back whatever is there. So this was the absolute path. And this is now getting rid of the last part. This is the dir name. But this only points to the bin directory. So I have to call it again. So now I'm calling OS path dir name on the result of OS path dir name. And this is how I get back. Okay, so this is incorrect here. I have to update it. This should be project root. Okay, I've just updated the location of the slide. So this where you have sys here, that's unfortunate. This should be project root. Project roots, yeah, okay. I'm going to update the slide. I just moved the examples to this new location because I saw that sys is confusing here and I forgot to update this part. But if I run this, so it's in the, I was here, I think, when I ran this, examples, project root, and then bin relative path explained. Okay, so you can see here that it says project root here. Okay, so I'll actually save it to the other file where and then that's how it's going to get to this place. Okay. So this is pointing to the root of the project, and then when I do the join here, I get this. Now I put in a variable mypath, I print it out, and this already points to the lib directory. Okay, and then you can import it. Yeah, I guess I'll. So there is an even better way to do this, but for that you need to learn about multi-level modules or packages, where you have a module that it's already inside a directory, and I think I'm going to skip that now. If you start with the flat version, that's already great, and then we can later on get back, maybe in an advanced course, we can get back to the more interesting ways of directory layouts. Okay. We talked a little bit about Python being compiled or not. What actually happens is that when you run a program, Python can keep the modules in a semi-compiled format on your disk. It's a file called the same name that the module, but .pyc, as it's in here. So when you import a module, what Python does, it actually looks for the name of the file .pyc, because and tries to load that. And if it can't find it, then it will look for the same name .py, load the module into memory, and save the .pyc version. So next time it won't need to do this compilation phase. It speeds up a little bit the loading time, but nothing else. So it won't speed up the running time. Okay. And one nice thing is that you can actually distribute the PYC files only, not the PY files. And then basically you hide your source code. A little bit, not much. Okay, it's not enough for many people, but that's one thing. These PYC files nowadays are in a subdirectory called _pycache. Okay, so I think if we look at it, projects, project root, lib, so you can see there is the pycache. And inside there is the PYC version, which is also includes the type of Python, which is called CPython in this case, and the version number of Python. So I could run on this computer several versions of Python, and it will create the PYC file, the respective PYC file for each version of Python. Because even though the same Python code can run on multiple versions of Python, the PYC version is already Python version specific. Okay, so it's more precisely fitting into this version of Python. Okay, it's just behind the scenes stuff, but it's also important to understand what are these pycache directories. So you can freely remove them once you start using version control. They are not supposed to be in version control. You're not supposed to keep them. Okay, it's just sort of like a little bit improving the startup time of your code. Okay, and then you should ask here now, okay, what happens if I have a PYC file that was created from the py file by Python, and now I change the py file? What will Python do?
I suppose create a new PYC file.
So when it encounters the PYC file, it also checks if there is a py file, and it checks if the timestamp is which is newer. And if the py file is newer, then it does the same thing and recreates and replaces the PYC file.
Yeah, but it replaces it doesn't create a new one, it replaces it. Yeah?
Yes, assuming that it's the same version of Python, yes.
Yeah, okay.
Yes. Yeah, so because it's sort of like, I don't know, is the word caching mean anything to you? Besides of getting cache out of the wall, or?
Nope, not really.
Okay, so caching, it's a whole story in programming that's not directly related here, but this PYC thing is sort of a cache, so that's why it might be a good way to explain. So for example, when you browse to a website, okay, your browser, you type in a URL, it gets to the website, which is far away, and brings the whole page to you. If you visit the same page again 5 minutes later, probably your browser won't go out and update your page unless you press Ctrl+R to refresh it. It will just show you the page that it already downloaded 5 minutes earlier. Okay, because it's caching it's keeping a version of the page on your computer in a directory. Okay, that's in order to improve the speed of the responses. Okay, it's a trade-off, because if something changed on that page in the last 5 minutes, then you won't see the change. Okay, that's why you have to press Ctrl+R usually to refresh a page if you know that something should be updated there. Okay, and this is the whole idea here, is called caching, and this thing happens everywhere in programming, because we're trying to reduce the data transfer time by saying, okay, if we brought something here already, then probably it won't, if we can assume that it won't change in the meantime, then there's no point of bringing it again and again. Okay, and this PYC file is basically that idea. Instead of compiling again and again the same Python file, it says, okay, we have already compiled it, let's save it on the disk, and then next time we can load it directly. Okay, yeah. We probably have to talk about caching a little bit more later on anyway. Yeah, so how does import and the from part work? I think basically I explained it already, that we're finding the file, loading into memory. That doesn't matter how. How did you write it? How you wrote import or from an import. And then, right. And then you are mapping the names, and that's it. So the loading part happens all the time. You could normally, okay, so normally you would put all the import statements at the top of your program. That's the recommendation. But we already saw that if it's a relative path, for example, then you first need to do some calculation and do some changes, and only then you can put import. And here I'm showing you an example that the order of the import, the statements. So import statements can actually be anywhere in the program. So if this is what we have in a module, what we have here is a function, but we also have some code which is in the body of the file, outside of all the functions. This will be executed at the time of importing the module. It's usually not a recommended, not a good idea to have any code there, because people usually not expect something to be executed at import time. But sometimes you do need to do some calculations. For example, finding out where am I? Okay, where is the module located? On what operating system I'm running now? Okay, I'm personalizing the module. Okay, I am. So sometimes it's important to have. Usually it's not recommended. But what really happens is, here is this program. So in the program, first I print something, then I import the code, then I call a function in the imported module, and then I print something else. And the result is that what happens is that here it starts running, so it prints it out. Then when I import my grid, then it will already print out loading my grid, so it will print out this one. Then when I call the hello, then it's printing out hello world. Okay, even though this is before the loading physically, but it's not happening before because it's inside the function. And then the done is when it's done. Okay, so the import, so whatever is outside of the functions happens at import time. That's the key part here. And then usually you shouldn't put there anything.
Can I just ask one more question back to the relative path and these sort of things? So when you from the import bit. So when you import a module, even if you're not giving it a place where it should look first, it will find it eventually, right?
No. Well, no.
So it wouldn't, because before you were showing, I don't know which slide it was. Yeah, here. So here you just showed that it looks in numbers of places, right? Or yeah. What? So if you try to import something, then would it just look at in the first one, or would it look in all of them?
No, it will go over all the list, and for each one of them it will check. But if this is some other place that's not in this list, then it won't find it.
Right. Okay.
Okay.
Yeah. Okay. Yeah. Sorry, I just needed to clear that up.
Yeah. Sure. Okay. And just you notice here, this is an egg here, because it's snakes and eggs, so yeah, programmers. Okay, so we were here in the order of things happening, and then what I would like to show that you can actually load modules conditionally. So you can say, okay, here I am importing random. Okay, that's always printing now start. I don't even know why do I have random here? I don't need it. I asking the user the name, and then if based on the name, if the user is called foo, then I import the mygreet module and call it. Otherwise, I just print no loading. I don't load the module, don't import the module. So import and load is sort of the same here. Why would you want to use this? You might ask. There can be a couple of things. One of them might be that you have a module that works only on Windows, and you might have a comparative module that works on Linux. And you want to load depending on the operating system. And then you will have to know how to check what operating system you are on, but that's beyond the question here, just the possibility. Another possibility might be that you have an application that can do all kind of very complex calculations. And usually you only want to do one or the other calculation. So there's no point in loading all the code into memory every time when you run this program. So maybe what you do is that you put the calculation of each type in a separate module, and then the main program checks, okay, I need this type of calculation, so I'm going to load this kind of this module. So this will reduce the initial starting time because you don't load anything, just the main program. And it reduces the total memory that the program takes because we only use the ones that you really need. Okay, so there are a couple of these use cases that it can be useful to load something on the fly based on some condition, let's say. What happens if you import the same function from multiple places? So here I have a module called mycalc and then also mymath. So as I import here and I call add, so it will print out 5. Here it will print out 6. It will print out 5 because now this one is using the add from mymath and this one is from mycalc. Okay. Yeah, it's just a stupid example it's not a good idea, showing that it's not a good idea to import the same function name from multiple places. Just as we discussed earlier, that's not a good idea to have a function that uses the same name as a built-in anything, print, sum, anything that or variable names. And Python doesn't complain about it. That's the main issue. So what you can do is install the pylint module. So let me use the opportunity. So type in pip install pylint. This command is going to install, we'll see it later on, but basically this command is going to install the pylint module. Here it went really fast because I already have it installed. Okay, it just checked that it all have the requirements. And once you have this pylint module, it comes also with a command line script, which is also called pylint. And then you can run pylint and name of the file. And let's just see this. So it's the duplicate add from module. Actually, it's here. Okay, so I run pylint and the name of the file. And if I don't give it any parameter, then it will complain about all kinds of things. I already showed you this, I think, but I like it, so let me show it again. So you show it shows all kinds of issues, but many of these issues, like missing module docstring, we don't care about this. What we really would like to is the important ones. So one way to do that is to add disable -c here. It's just a flag to pylint. Okay, And this limits, so you can see that these are these letters. So I think this C is just, I don't remember the name for this, but these are just generic things, generic issues, not that important ones. These are warnings, I think. That's the W. So we are I disabled all the C-type messages because I said, okay, that's not important. Let's focus on the important ones. So this actually says that, okay, it's re-importing something. And then you can combine this once we learn also testing, we can combine this, and then you can always check that your code doesn't have any of these issues. Right, this is the output, okay? Okay, we discussed this at the beginning of the course. You probably don't remember because I already, back then I told you that's not important. You can take a file which can be used both as a module and as a script. Okay, why would it be useful? It's probably not that useful actually. Okay, but people still put. I know one place where it's critical to have this, but that's some advanced part, not that important now. Just remember. But in general, I don't find it really useful. I would probably prefer that people decide this is something that I would like to run. This is that I would like people to use as a module. But in any case, you will encounter this. So at least let me show you why is it there. So you'll see this kind of expressions in many code. And that's why I would like to explain it, because you will see this. Okay. So Python has this variable called _name. Okay, and this variable contains what you might remember. I asked you how do you call yourself? Okay, and you said that you call yourself Nora, but then we agreed that no, you call yourself I or myself, or okay, and other people call you Nora. So that's the thing. So the _name is how other modules, other scripts call this file, or how the file calls itself. Okay. So if I run the file which is called my module as Python name of the file, then it will say namespace in my module is well, namespace. Don't worry about that expression. That I am called main. Okay, so here, okay, my name is main. Okay, that would be, I should update this text. Okay, my name is main. Okay, so my name is main, and then because my name is main, that's why this expression is true. Yeah, okay, and this is why this function is going to be called, okay, executed, and that's how this function runs. So this is why I run in main. It's still called main. Okay. But what happens if we import this my module, the one that we had earlier? Okay, this my module, we are importing it now in another file, and then print out my own name, and then we run the function from the other module. So first of all, it prints out a namespace in my module Py. So the name. So this namespace in my module Py, okay, this is this function. What I mentioned, that the import actually executes whatever we have here. And I'm putting it here only to show you. In this time, the my module calls itself my module. And my program, the import my module, my own program, calls itself main. So, okay, which one is the main
very
program?
confusing.
Okay, which one is the main program now? Which is the main file?
This one. Import my module.
So this function, this file is now the main file. So this calls itself main.
Yes, okay.
And the other one calls itself my module.
Right.
But when I executed it directly, then it was itself the main.
Yes, okay.
Yes, it's confusing, I know. That's why I was, it's sort of something which is confusing. I'm trying to explain it anyway because you'll encounter it and then you'll wonder why it's there, okay? And then I call the run from the module as well, which still calls itself my module, okay? So this is basically what happens. So if I didn't call here the run, then this wouldn't be executed, okay? Because in this case, in the second case, when I'm running the import my module script, it imports the my module. And when we get to the importing, it says, okay, I'm printing it out, but my name in this time is not main. My name is my module, so I won't run it. Okay?
Okay, yeah, I think I get it.
So this way, this file, the my module file, can be executed as a program, so I can run it Python my module, or can be imported. Yeah, and even if you use this form, so the from my module import run is the same behavior. Yeah, we can skip this one. That's not really important. Actually, we saw this already, so we don't need that slide. I went over the slides and I got to the conclusion that I have a few too many slides here. And this slide only shows that if you try to import something, so import a module, and that module imports something, and then but you also import that something. Okay, so if the same module at the end are imported in various places by your application, it's still loading only once. Okay, so actually loading into memory happens only once. It's interesting because many times, especially when you're writing a big application, you're going to rely on modules written by other people. And maybe both of them are relying on some central module. Okay? And you start wondering, okay, now all of them loading separately? And the answer is no, that only once it's loaded, that central common module is only loaded once. Okay? Questions here in the modules chapter?
No, I think I asked everything I wanted in the meantime.
Okay. So exercises. We keep going back now to the same exercises. So now the idea is to go back to the functions and split them up into functions and then move them into modules. So you have some code in a module, some code in another file. So we'll see how you can just use a module just to put in some code separately. Okay, don't forget about it. It's not that important. And here is just more of the same thing. So basically taking a module, creating a module that has a function called div, and another function called add, and then start using it. Okay, so a couple of these ideas, not really. There's not a lot of new ideas programming wise here. It's just the technique of putting something into separate files. Okay, take some script, and we saw. So for example, you can take what we had in the exercise, in the solution, the merge sort, and take one of the functions, put it in a separate file, or create a file that's the module called merge sort that has all the functions in it, and from a separate file use it. Okay, so these are just small ideas that thing. I skipped the doc. I removed the doc text slides from the slides, so this exercise is irrelevant now. Okay. Don't worry about that. Okay, so these are the exercises. It's basically taking some of the previous solutions and trying to take them apart into functions and then later on into modules. Okay. Thank you for watching and enjoy your exercises, and I'll see you in the next video.
See you.